What's up, y'all? Welcome to the video. Today we're continuing our survival shooter game, and we'll be covering our basic enemy AI setup via behavior trees and some simple movement related tasks. In the last tutorial, I covered how to set up our player heads-up display as well as binding values to it from the player such as health and ammo. We also went back into our player class to implement our reload functionality. If you haven't already, I highly recommend you go back and watch that video because it's going to be very helpful to us moving forward with our gameplay. And with that said, let's get right into our implementation for today, starting with our behavior tree. So the first thing we're going to want to do is we're going to want to find our way over to our AI folder. And we're going to right click and we're going to create a new, go to artificial intelligence, we're going to go to behavior tree. And we'll just name this BT enemy BT. And if we open this up, now if you aren't familiar with behavior trees at all, this is the AI system's main decision-making architecture. And we'll go a little bit more into the structure a little bit later once we have some tasks. But for now, we're just going to save this and then get out of there. And we're going to then make our Blackboard. So go back to artificial intelligence, go to Blackboard, and we'll name this BB enemy BB. Open this up, and right here in Blackboards we actually hold a lot of keys for different values, so we can hold a boolean, a vector if we're trying to keep locations, all sorts of stuff. And the Blackboard interacts with the behavior tree usually, so if you have a task that the behavior tree is trying to run, it could use Blackboard values to make its decision or know exactly, for example, if it's a vector, it's going to know which location to go to. So with those both created, we're going to connect them. And for our behavior tree, we'll go over here, Blackboard asset, connect the one we just made. And we'll get a little bit more into both of these once we have those tasks created. But without further ado, let's get right into our class setup. So now in our classes, we're going to want to make a new C++ class, and we're going to start with our enemy class. So we're going to make this inherit from character, and we'll just call this enemy. All right. And we have our default character, header, and CPP. We're going to implement more into this a little bit later, but before we do anything, we need to have our AI controller connected so we can have our behavior tree initialized and we can have our actual decision making connected to our character. So let's get right into that. So if we go back to Unreal and go back into our classes, we're going to make a new C++ class. And we're going to make this inherit from AI controller. Now, you will see that it's not a common class. So if you go to all classes and you type up AI controller, we'll make it inherit from here. And we'll just call this enemy controller. Reload this. And now we have our enemy classes and our enemy controller. First thing in the enemy controller, we're first going to public, and we're going to start with our constructor. So a enemy controller, and we're going to feed into an F object initializer. AP object init. And now we're going to have some override functions with begin play, override, and we're also going to have void on possess, override, but this is going to take in a pawn. Now we're going to take in our tree components. And this is going to be U property, edit instance only, blueprint, read write, and category is AI. And the first thing we're going to pass in is going to be a class U behavior tree component. I'll call this MP behavior tree component. And we'll do the same thing with this, but instead of a component, we're going to do a behavior tree. Now the last thing we'll want to do for our header here is we're going to want to make a private, and we're going to pass in our Blackboard. So class U be Blackboard component MP Blackboard. And we are also going to need a function to get that Blackboard. So we're going to make another function here, Blackboard. And that is going to be a class U Blackboard component get Blackboard. Now getting into our CPP, we're first going to want to make some definitions for this. Create definition. Okay. And before we start this, we're going to need a couple of includes. So include behavior tree components.h, and we'll copy this because we're also going to need behavior tree.h, and we're going to need Blackboard component.h. And lastly, we're going to need uObject constructor helpers.h. Okay, now starting with our constructor here, we're going to call static constructor helpers fObject finder U behavior tree, and we'll just call this tree finder. And what we're going to pass in is a text block. And what this is going to be is the reference to our behavior tree. So if we go back into Unreal, right click our behavior tree and copy reference. And we paste that in, and now we have a reference to our behavior tree class. And if our tree finder dot succeeded, then our MP behavior tree is now going to be equal to our tree finder dot object. And let's check my spelling. Perfect. So what this is doing is this is getting the behavior tree directly from our reference. And the last thing we're going to want to do in our constructor is we're going to want to initialize the tree and Blackboard components. So our MP behavior tree component is going to be equal to AP object init dot create default subobject of our UBehaviorTree component. And we're going to name this, first we have to pass in this, then we're going to call this behavior tree component. Now we're going to do the same thing for our Blackboard component, but we're just going to switch out the class. So Blackboard component. And this is going to be equal to a Blackboard component. Blackboard component. Okay, that should be all set for our constructor. Now getting into begin play here, we're going to call a super to begin play. And then we are going to run our behavior tree. So if we call run behavior tree, MP behavior tree, and lastly we're going to start the tree. So with our MP behavior tree component, we're going to call start tree. And we're going to pass in our behavior tree. Perfect. Now on our onPossess method here, first thing we're going to want to do is we're going to want to call super again. So run our default possess method. Super onPossess. We'll pass in EP1. And then we're going to want to initialize our Blackboard. So if np Blackboard, np Blackboard, initialize Blackboard, np behavior tree Blackboard asset. Okay, that should be pretty much everything. The last thing we're going to do is we're just going to have our get Blackboard return our Blackboard. So np Blackboard. So that should be everything that we're going to need for our AI controller class. Now we're going to go back and we're going to make a couple more classes, and these are going to be our behavior tasks. Just for this video, we're going to be making the movement related tasks. So first we're going to need to get our player location somehow. So we're going to make a new C++ class. And this is not a common class either, so we're going to go back to all classes and we're going to search up BTT. So BT task. And we're going to use our Blackboard base right here. The reason we can't use blueprint base is because this is not usable for C++. So we're going to stick to this base right here. And we're going to just call this BTT find player location. And the reason we're having a task specifically just for finding the player location is because our enemies are always going to be chasing our players. So but they're always going to need to just be looking towards one location. So we'll create that. Okay, we've got our class right there. And the other task that we're going to need is for chasing the player. So we're going to make another BT task, Blackboard base, and we're going to call this BTT chase player. And now that we have our classes set up for this, we can now get into implementing them. Starting with our headers here, we're going to go into findPlayerLocation.h. We're going to make a public section here. And we're first going to create our constructors. So ubtt findPlayerLocation. And we're going to pass in an object initializer in here as well. So fObject initializer. Const AP object in it. And lastly, we're going to make a method called execute task. And what this method is about to do is it's going to be what is ran every time that our task node is called upon in the behavior tree. So it's going to be more or less like a tick method. So every time this task is called upon, we're going to carry out the task. So to do this, it's going to be ebt node result type. That is going to be our return type, and execute task. And this is going to take in a behavior tree component. And we're going to call this, it's going to be a uBehavior tree component. And we're going to call this AP tree component. And we're also going to pass in the node memory. Node. Okay, and the header here is going to be very similar to the one on chase player. So we're actually just going to go and copy this, but change the name. It's going to be ubtt chase player. Okay, and that should be all set for our headers. Okay, so with that, now we can start implementing our CPP. But real quick before we go and do that, we're first going to want to add a new header file, and this is going to include references to all of our Blackboard keys. So we're going to need these references once we're implementing our different tasks, because whether we're getting or setting a Blackboard key in here, we're going to need to be able to reference those in C++ code. So what we're going to want to do is go to add a new item, add a header file, and we're going to name this enemykeys.h. And once that's created, you'll have an empty header file. And before we do much with this, we're first going to need some includes. And this is going to be runtime core public uObject name types .h. And the last include we're going to need for this is runtime core public containers unreal string.h. Now that we have those, we're going to create a new namespace, and we'll just call this enemy keys. And what we're going to put in here is a tchar const. We'll name this target location, and we're going to set this equal to some text, and this is what the text is going to look like in the actual Blackboard itself. So whenever we're referencing the Blackboard, it's going to be the key target location. So now that we have that, you can add more keys as you go, as you're developing your own AI, but this is all we're going to need so far since we're just developing a chase functionality. Now going back into our CPP, we can now start implementing this. So we're going to need a few includes. First, we're going to need behavior tree Blackboard component.h. going to need our runtime navigation system, public navigation system.h. We're going to need our enemy controller. We're going to need the header that we just created that holds all of the references to our keys. And lastly, we're going to need Kismet gameplay statics. And this header is going to allow us to actually grab the player reference. So first we'll start with the constructor. The only thing that we're going to need in here is the node name, and we're going to set that equal to text find player location. And the only thing that this is going to do is once we are looking in our behavior tree and we create a node with this task, it's just going to be labeled find player location. Now getting into the execute task, first we're going to want to get our AI controller. So we'll do auto const p AI controller is going to be equal to a cast of a enemy controller, and we're going to do ap tree comp get AI owner. So we're getting the AI controller. Next, we're going to want to get our navigation system. So u navigation system v1 p nav system. It's going to be equal to u navigation system v1 get current get world. And the last thing we're going to want to pull is a reference to our player. So get the player reference. So we're going to get our a player controller, p player controller to be equal to u gameplay statics get player controller get world and index 0. And from that reference of our player controller, we're going to want to get the pawn from it. So a pawn p player is to be equal to p player controller get pawn. Now that we have all of our references, we are now going to get into setting the player location. So if our navigation system is valid, we're going to call upon our AI controller, get the Blackboard, and we're going to set a value as a vector. And we're going to call enemy keys target location, and we're going to set that as our p player get actor location. So if our system is valid, we are setting the Blackboard value of the target location to be the player location. So setting location to player location. Now, we're going to want to then finish the execution. And we'll do this by doing finish latent task that's going to be p tree comp abt node result succeeded. And lastly, we're going to want to also return this. And that should be all set for finding our player location. Now, getting into our chase player functionality, a lot of it is going to be very similar to this task right here, except rather than setting the player location, we're actually just going to be getting that player location and then telling our enemy AI to move towards it. So we're going to take these same headers over here, paste them right in there, take this, paste it into that. We're not going to need our player reference. And we're not going to be setting any values here. First, in our constructor, we're going to change the node name to be chase player. And inside of here, we're first going to get location of the player. And then afterwards, we're going to tell the AI to move. So to get the location, we're going to do an f vector p location. It's going to be equal to p AI controller get Blackboard get value as vector, and then enemy keys target location. So what this is doing is the controller is getting the Blackboard and it's looking towards the Blackboard key of target location, and it is then returning the vector value that is currently stored in target location. And we are constantly going to be setting that location in this task right here. So the enemy is always going to have a reference to where the player is. And now once we have our location, we are now going to do p AI controller move to location p location. And that is going to conclude everything for our movement tasks. So with that, we're now going to go into putting everything together. So we're going to make a blueprint of our enemy, and we're then going to hook up the AI controller, set up the behavior tree, and test out our movement. So back in Unreal, we are going to head over to our enemy right here, and we're going to create a blueprint class based enemy. And we're just going to call this BP enemy, and we're going to put that in our AI folder. And the mesh that we're going to set for this is going to be our corpse melee. And we're just going to move this guy down a little bit. Awesome. Okay. So now that we have our enemy initialized, we're now going to go into here and we're going to look up controller. And we can now change our AI controller class. We're going to change this to enemy controller. We're going to go in and update our Blackboard here a little bit. So the one key that we had added was target location. We want to make sure that the keys that we're using do match the Blackboard that we have in Unreal with what we're using in C++. Otherwise, you'll run into issues. And now we can go into our behavior tree, and we're going to do a selector. Now, usually a selector will only choose one based on a condition, but we're going to just have that go straight into a sequence. And in a sequence part of a behavior tree, it's going to go from left to right, playing each task one at a time. And once it's finished, it's going to play the next task. Unless you add like something like a delay in here, then it's going to delay that task. But first thing we're going to want to add is our find player location. And we're going to pass that into target location. And once you have the player location, you're now going to want to chase the player. So chase player. It's going to be target location as well. So pretty simple setup. all this behavior tree is pretty much doing is it's going through a sequence. It's finding the player location by calling this task right here. And then it is right afterwards chasing the player once it has that value set. So all this enemy is going to do once we have it hooked up completely is it is just going to continuously chase the player. Now, what we're going to want to do is, now that we have that set, we're going to go into our level and we're just going to plop this enemy right down here. And we're going to playtest that. And as you can see, our enemy is constantly chasing us. Now, one thing you're also going to want to make sure you're doing is you're also setting the navigation bounds. So we're going to go into volumes, nav mesh bounds volume. And we're going to set that right around here. And we're just going to change the size of this to be 20 by 20. And if you want to see the actual overlay of where this navigation system is overlapping, you press P, and you can now see everywhere that the nav system is covering. And now our enemy is constantly just going to chase us. Okay, now, while he is constantly chasing those, and that is a very good thing, he is also way too fast. So if we go into our movement component, and we change his walking speed from, max walk speed from 600 to, let's say, let's change it to 300. Cut that in half. He should be a lot slower now, and we should be able to outrun him very easily. Perfect. Now we have something moving for us to shoot at. It's not going to take damage quite yet because we don't have that functionality implemented, but we will be getting there. Alright, well that is going to cover everything for this tutorial. We now have our basic enemy functionality set up with some basic movement tasks. In the next tutorial, we'll set up the enemy's animation blueprint and get right into implementing its attack logic. Thank you so much for watching. If you're enjoying this tutorial series so far, be sure to drop me a like and subscribe. I'll see y'all in the next video.